Hello, everybody. How are you? And welcome to today's webinar here at UPRI. Well, it's hosted by me, Adam Hartmann, and Jakob. Welcome.
Thank you very much.
Welcome to you out there. Well, so I will just give it a couple of minutes for the rest of you to show up. And so we will start in about approximately 5 minutes. So if anybody have a cup of coffee heating in the stove, then feel free to grab it before we start. Let me see. So, right. Welcome. Right. We will start in a couple of minutes, and thank you all for being here. I expect us to begin in 3-4 minutes, and until then, if anybody out there is from a different time zone than European Central, then well, shout out in the chat and see if it works.
Absolutely, and I would love to hear where you're from. There's been a lot of different signups for this webinar, so would love to hear where you're from the world.
Hello, Daniel, Halian. Yeah. Oh, that's great, and there's already
some questions.
That's perfect. We're gonna definitely come back to that. So I have a question: are there guidelines which define summer-winter mapping period in order to perform warehouse mappings?
That's a perfect seminar to join up for, because that's actually one of the questions we're gonna answer. So
nice. Okay, cliffhanger. That's good. That's good.
That's gonna be very nice getting started then.
Hi, David. Right, and well, where we are from Copenhagen in Denmark. That's that north of Germany, and here the summer has finally come. So that kicks off a good reason to start discussing summer mappings, right?
Absolutely.
But I assume we have other people from I can see that from all over the world where summer started maybe a couple of months ago. Well, what we define as summer up here might be not real summer from where you're from.
Absolutely. And we have one joining from Denmark. Nice to see you.
Oh,
it's gonna be a lot.
Yeah, great. All right, and also from Kentucky, Miami. Perfect. Good to see you around. Nice. Raining in London.
Yeah.
Well, yeah. Isn't it like that? When it's raining in London, the sun is shining in Copenhagen, and vice versa.
I think so. Yeah.
That's so we shared half and half of here.
Yeah.
I lived in London back in the days, and that was, I think, in 2008, and we had real winter, like real snow. And apparently that was like a really rare thing in London because the city is like heated up constantly. So the snow can't really, settle. So we were like, not skiing, but at least, having fun and playing around in Hampstead Heath.
Okay, yeah.
And which apparently is a really like it's a special thing in London. I don't know if you can confirm that, Olivia.
Yeah, I can see someone joining from Dubai as well. 38 degrees.
That's summer mapping time.
That's a summer, at least for us here in Denmark.
Yeah, that would be summer mapping. What is I assume like 38 is, that might not even be a hot season yet, but it sounds very hot though.
Wow. Absolutely. Should we
kick it off?
Should we kick it off?
Yeah. So now, we're 4 or 5 minutes in, and it's just the beginning. Oh my God, Anas. Well, I hope you maintain it down there. But at least today we're gonna talk a bit about summer mappings, and 47 to 48 degrees Celsius. That's serious, right? Welcome, Jakob. Welcome to you, audience. I'm very excited to host this particular webinar because it's something that we do a lot, and we are entering to the season where summer mappings is the hot thing to discuss.
It's the hot topic. Absolutely.
I'm just gonna mix my screens. Can you out there confirm for me that you are still watching the presentation that we prepared for you? Let's see, Jakob. It looks like we can see it on your screen, which is supposed to be the right. Yep.
If you
Thank
can't
Olivia.
see anything or hear anything, please let us know, and we'll have someone ready to fix the technical issues.
Yeah, because I look and I consider myself as a DJ in this room. So right now I'm looking at this kind of like massive piece of instruments in front of me where I can shift like screens and voice and everything like that. And once in a while I really like miss something out, and then we realized that, you know, the picture of Jakob and I wasn't really on for a very long time. So if you see something like that, it's not intended. Then just say something in the chat. So we are really happy to have you here to discuss the
we're going to discuss GxP-compliant summer mappings, and it's going to be very exciting. It's one of the questions we get a lot, especially regarding summer mappings as contrary to winter mappings. But it's something that's really in the season now. We have a validation team that's in a bit of a hurry right now, because there's large parts of Europe are in summer or starting up on summer, so all the protocol work is going on. So it's going to be very interesting, I think, to dive into some of the topics regarding summer mapping specifically, and then touching base on some other stuff as well related to mapping. Yeah, nice. So absolutely excited to get started.
And a bit about us.
Yeah,
Jakob, we started up GxP 10 years ago.
Yeah.
Actually, almost 10 years ago, isn't it
almost
crazy?
Almost to the date. Yeah, exactly.
Yeah, and we've been through a journey, and now we are hosting a webinar today. And I do believe that both of us are actually still like officially on parental leave.
Yeah, I mean, it might be at least part-time. So a lot has happened the last 10 years.
Yeah, so we're both on 2 kids. That's the second batch that we are in parental leave.
10 years and 2 kids ago, yeah.
But Jakob, tell me a bit about yourself.
So my role in GxP is as head of quality, where I oversee both our validation teams. We have validation teams performing equipment qualification, and also a lot of thermal validation, thermal and relative humidity validation for our customers, and also all of our internal calibration, our calibration laboratory, which is an ISO 17025 accredited laboratory, has been for the last 6-7 years. And also all of our internal validation. So there's a lot of different things, but really truly mapping is one of our one of the topics really dear to my heart. So I'm really excited to talk about this. And Adam, what about yourself?
Yeah, and then before I head to me, I always like brag about you once in a while, and when I have the chance, and now I have the chance because I have people sitting in front of you, and they're kind of locked in to this. So Jakob's also a space engineer background, so we all often have like really interesting discussions about what's happening around the world, basically.
Yeah.
But besides that, I have a background in engineering also. I worked with UNICEF back in the days, and that kind of kicked off our venture in GxP, working with delivery and cold chain distribution. And we kind of led our way into this field with curiosity and a playfulness that is today driving our interest within the field. And also my interest into this, I really believe that there is a lot we can do, and there is a potential to really reform the way we work and handle with drugs and medicine that can potentially benefit people out in the end, even though we sit here as quality experts and talk about a very particular specialty within the field. I do believe there is a potential to use this to something much bigger, and that's what really drives me.
Absolutely.
So today I have a role as CCO. That means commercial officer in GxP, and I run both our marketing, our sales, and our customer relationship work with teams in US and here in Copenhagen.
Absolutely.
Before we head on, maybe just a very short introduction to why we are capable of talking about this, because like Jakob said, a big part of our work is about validation and mapping and thermal validations, etc. Also calibrations, like Jakob said. But all in all, we run with a very holistic view upon temperature compliance, and we kind of like look upon ourselves as this one-stop solution for guaranteed temperature compliance. And then in all, that means that we kind of encompass and create products and services around all these areas that you see on the screen in front of you: mapping, ongoing monitoring, validation work. And all in all, what it provides to our customers the ability to get through an audit very easily. And that's kind of what drives us on our daily venture, basically, on trying to innovate this field. But it also gives you an idea about, when we talk about mapping, we often also talk about what happens afterwards when you enter into monitoring, when you enter into the afterlife of whatever you are working on. And it gives a slightly different kind of perspective on how we look at things and the scope of things that we talk about.
Absolutely. Yeah. And therefore also mapping is really one of the key parts that we do. We often tend to help our clients with first the mapping, if there's a new warehouse as an example, and then afterwards the monitoring and the validation of the monitoring equipment as well. So definitely it's one of the core elements, absolutely, to our business.
Nice.
Yeah, but deep diving into some of the topics for today, as the title mentions, we're going to look at summer mappings and how to handle summer mappings, and some of the core elements. We're also going to just touch base on the mapping process itself. It's something that we've had several webinars on, and I would also highly suggest watching our recordings. This webinar, it's not going to we're not going to talk so much about the mapping process itself, but more try to focus on what's really important when dealing with the summer mapping, as contrary to a winter mapping or some other mapping not influenced by seasonal changes. And then I've picked out 5 topics that I think are great. Some of the questions that we often get, asking when is summer? That's a question we often get, at least. Talking a bit about how the sun and radiation heating can have an influence on where to place data loggers and which kind of tests to do. We're also going to touch base on the outside air temperature, how that can influence the mappings, windows, and also equalizing product temperatures. And then we're going to have a QA at the end. But when we normally do these webinars, just shoot us a question in the chat, and we'll try to take it along. This is all for you. So please, if there's anything you would like to ask us along the way, just ask them in the chat, and I'm sure we can have time to answer some of those questions along the way. But just kicking out here, just the mapping process itself. There are a lot of different, I should mention, by the way, that often when we're talking summer mappings, we're often talking about warehouses or larger buildings, as normally if you have a fridge or freezer or cold room, those would be inside of a building that is temperature controlled. And as such, it's not really going to be affected by summer or other seasonal changes, basically. But another thing is there's a lot of standards and guidelines on the topic. There's the ISP guideline for controlled temperature mapping and monitoring, and there's the WHO technical guideline. The WHO guideline is free, and we'll share that if anyone wants to read it. But one of the things that is often not mentioned in these guidelines is, where does this fit in our process validation approach with our V model? And this is basically how we view it, that mapping is a qualification exercise. It's basically meant to test the operation of a warehouse, as an example, and also test the performance of a warehouse. So that's normally where we see temperature mapping fitting in a validation approach here as a V model. And it's really one of the key things to keep in mind when discussing temperature mappings, but also writing the protocols, conducting all the exercises, that this is something where you should test both your user requirement specifications and your design specifications, and some of those risks, which is also one of the things we'll touch base on today. Really remember that this is a qualification exercise, so you should have what the acceptable ranges are, what is the expected output of this, should be prepared in advance. I could talk a lot of time on specifications, but this is just to give you an idea of where in the process are we when we're talking temperature mappings. And the basic process, as also dictated by most standards and guidelines, is that you make a protocol in which you outline the purpose, the scope, the methodology for how to prepare this and conduct the temperature mapping. Temperature and relative humidity could also be included. You have the execution phase where you set up your data loggers or your sensors, collect data, make all the documentation ready, run all these different tests. Again, we're not going to so much into detail. And then we have the reporting at the end, really reporting on the results that were found and concluding on whether those results on that data was within the acceptable ranges. So that's our basic approach, a three-step approach to qualifying an equipment, and thereby also helping in validating a storage process. There's a few things though that we often see our clients having problems with, and that's most likely the placement of data loggers. Where do I place them? This image is from the WHO guideline, and it pretty much outlines that you should place loggers in a grid, and those should be spaced so and so far apart. You should have 3 in height and 3 in length and 3 in depth, so that you have 3 data loggers on all axes. But one of the things that I really want to get down to is that I'm personally view this more as a rule of thumb. It does not really apply the risk-based approach, and that's where a lot of the things we'll go through today is pretty much an input to the risk-based approach. I personally believe that just applying the placements from the standards and guidelines does not give a full image of where the risks are and whether you've measured those risks and thereby also being able to mitigate them. So in my view, a much more risk-based approach should be used in terms of where to place data loggers. It should, in a grid-like structure, it's basically because we want to ensure that the temperature is the same or homogeneous and within acceptable ranges for all placements within the facility. It's not to fulfill some guideline specifications of where to place sensors. It's to mitigate risk. And that's one really important thing to keep in mind. Another part of it is that you need to choose on which type of tests you need to do. So, you might have heard of stability tests where you leave the facility alone and let it run for 1 day, 3 days, 7 days, whatever is suitable, both empty and loaded. There could also be power failure tests where you try to see what happens if the power fails and you need to get the HVAC system back up and running, how fast you need to do that. And normally we would also see door opening tests. So opening doors for predefined amounts of time and a predefined frequency, and then seeing how that influences the stability and homogeneity of the temperatures within that facility. And that is also one of the things that's going to be affected by the summer season. Can I? Yeah. Yes. And this is often as well why we've chosen this model with 3 different risks. That's how our validation team approaches this task. And that's a model that we have developed in here in Newbury. And that's basically when we are having, let's say, a warehouse in this case, we'll always try to think of 3 different types of risk. That's compliance risk. So basically, what's the risk that we don't comply with any of the standards and guidelines and how they outline your approach, the amount of tests, the duration of tests, and the placement of data loggers. Of course, all the different standards, but this is most of them. We'd also always look at technical risk. That could be such as HVAC systems, where they placed, how do they operate, do you have any chargers in a warehouse? Forklift chargers is often a culprit. It heats up at night when you plug in the forklift, and it gives off a lot of heat, as an example.
Right. And you might not, have them within the stability test. Also have the forklift placed.
Exactly. That's really one of the things you should keep in mind. It could also be windows. Mm-hmm. Even though they're covered, they might have an influence that sun shines through windows and heats up material. Different types of wall material, the insulation, doors, how those are insulated, how they work. Those we call technical risks. Those are related to the technical installations and the way that the warehouse is set up. And then lastly, we always look at operational risks. So that's how do you use the facility? How often do you enter? Which doors do you enter, or gates? How many trucks arrive per day? How do you load and unload? How you use the facility, basically. That should also be part of your risk. approach. And this approach, by looking at these 3 different risks, is something that we do every single time. And it really requires a holistic view or a nice overview of how the facility is to be used. It's impossible to do this, I must mention. I guess there's a lot of people from quality departments around here. It's impossible to do alone. We've tried it. You need the operational team in there to give you hints on how this facility is going to be used. And that's the same for smaller units as well. But we always look at these 3 different risks. And that's one of the things that I believe that the standards and guidelines really don't emphasize enough, that when they propose positions of data loggers, that's actually because we have risks. And the basic risk is, are temperatures within the acceptable ranges for all positions? So that's basically the underlying risk. And for the grid selection, the loggers that we normally place in corners and in the center and in 3 different heights, depths, and lengths, as I mentioned, that's basically because we have a homogeneity risk and a stability risk, one might say. But we also do need to apply risks that are based on, as I mentioned, HVAC systems, blowout air, doors, windows, gates, forklift chargers, all these different things. You need to consider all the different types of risk. We're seeing an increasing amount of auditors looking for the risk-based approach being applied, and you cannot do that purely by following the standards and guidelines, because you don't apply your own risk-based approach. You haven't considered the use, the technical installations, but only the compliance and thereby the standards and guidelines.
I believe this is a very interesting and crucial point. We discussed this just prior to the webinar, Jakob, about this kind of mindset change, because we've been talking all about this, applying a risk-based approach, because it's smart. You can save time and you can focus where your effort is,
where the value is, basically.
Where the value is. But you also now apply kind of another aspect of it, that the auditors, they won't accept that you just follow the protocols.
I think our example from our conversation, as you mentioned, Adam, nobody got fired for choosing IBM, right?
And if you just follow I've done everything that I was appointed to do in my compliance work, but we see a trend at least.
I think we're seeing a trend, whereas in the past there was no one got fired for following the ISP guidelines, and now we're seeing more and more auditors looking for risk-based approach in which you've identified your risks yourself, because just following the standard placements from the standards, we see in more and more cases that that's not enough, because it doesn't really apply to all scenarios. The standards are great, don't get me wrong, but you need to apply your awareness of the operation and the technical installations and so forth of the facility in order to really satisfy auditors. It's something we could talk about for a long time, but I think just these elements, keep those in mind, and just to have those sort of as an example. This is not a real warehouse. It could have been, but this is just me trying to point out all the different risk areas we might have in an exemplary warehouse. We have all the gates, air and sunlight might be coming through. The gates might be heated. There's a little bit of foreshadowing here. We have personnel entrances. We have offices. We have HVAC units blowing out air that might be non-compliant, forklift chargers, and you could come up with at least 10 more. But it's just to be aware of placement in grids near where the products are stored is not the only risks that are apparent in a warehouse like this. There's a lot of other areas where you might have placements. And in this example, like the center area might be used for temporary storage. Well, then we need to apply temperature mapping to that area as well to ensure that we don't have like 6 hours where it stands on pallets on the floor where it's basically non-compliant.
Jakob, can I ask a couple of questions there? Because a location like that, now we're talking a summer mapping, right? Where the windows are, where the gates are, there might be a risk of obviously a hotspot not being recognized or something like that. And then same part, placement in the grid will, in a window mapping, maybe potentially show there's a cold spot.
Yeah, and that's actually one of the topics we'll go through today and explain in much greater detail. And that's also one of the points from today's webinar, is that you have radiation heating. You don't have radiation cooling. So where the sun is, like physically on the sky and which side is facing, has a huge impact that you would not necessarily see in the same way during a winter mapping. Yeah, okay, that's a really good question for Catherine. I think you actually got the point exactly you asked. With new facilities, would you recommend a grid-like approach to start and then repeat with a second placement based on risk? Spot on, Catherine. That's exactly how we do it as well. The grid-like placement is a really good starting point because that's a risk. We monitor for the risk of inhomogeneities, just in the volume that's being used, and then we add on, one might say, the other technical risks that are there with the blowout air from HVAC systems or doors, gates, and so forth on top of that. So normally we would see an approach where you have grid, normally we call them rationales. Why did we place this logger there? Would apply the grids first, and then we have the other risks, which are radiation heating or conduction heating and so forth. But we'll get. I'll promise we'll get much more into detail with this in the points here. Yeah.
Yeah. Okay. There is the formal way of doing mappings, and you follow the protocol, and then design the grid, and then you move it around and stuff like that. But what about we have data loggers that are wireless, and they're like live, so you can see things immediately. Don't you actually also do a bit of informal kind of like preparing stuff when you start up, and then just throw the sensors out just to see, like, is the picture that we have in our mind actually the right one, or how do you actually do this?
That's actually a really good question. One of the things I would highly recommend in relation to a summer mapping is actually either renting or buying a thermal camera. Those do not give precise measurements or accurate measurements in any way that could be sort of used, and they also show surface temperature, they don't show air temperature. But we've done a lot of cases where we can see that gates, which are perfectly well insulated, are unfortunately also painted black in the sun-facing side. So those will heat up and radiate a lot of heat, and that's how we identify a risk zone where we might otherwise not have, just based on the floor plan. So there are a few things, and also just being on site. Often you can feel, actually, if it's a really high source of heat, you can actually feel the radiation. The human body is actually quite capable of feeling it. And also cold, if you have a leakage air from an HVAC system, it's actually quite apparent. But a thermal camera, they're not that expensive. You come a long way. But also, as you build up competencies and experience with this, you'll start to identify those zones at a much better pace. But there are a few technical remedies one could use. But the on-site visit is actually an important one, right. Although it requires you to drive somewhere. Just moving on, as I mentioned before, the mapping process, often related to summer mappings, can have an impact on placements of loggers and tests. And that's basically what we're going to go through today. Yeah. So why do we talk about summer mappings? Also one of the questions we get. A lot of the standards and guidelines will dictate that you perform a summer and a winter mapping. Again, I don't think that's the full picture. The underlying reason behind this is that we want to test it at the extreme temperature ranges that we might experience, or that we're likely to experience.
48 degrees in Dubai.
So that's actually one of the key elements, that it's really location based. So finding out when it's summer really has a lot to do with where you are on the globe. Basically, it's part of seasonal mappings. It's just part of testing at the extreme operating ranges, and we're just used to saying summer and winter mappings. But really, it's about testing at the extreme temperature ranges that there are. So
what about humidity, actually? Like, because there you have the relative humidity might be, or the absolute humidity.
I mean, that's a whole story in itself, relative humidity. But yeah, exactly. I mean, you want to make sure that if you have requirements for the maximum ranges of humidity, that you test for those in the most extreme seasons as well. Specifically, if you're in parts of the world where there's not so much summer, winter, but more rain season and non-rain season. Absolutely.
Cool.
But before time runs out here,
sorry.
What's also apparent from summer mappings is that we'll have a high outside temperature. It might not be so apparent, but it's one of the things to keep in mind that the temperature of the air also increases, and you have also a lot of radiation heating, and that's one of the key elements we'll go into in just a short while. I just need to get this. Yeah. One other point as well is remembering that when you need to cool down, at least if you don't have a very hot storage zone, is that your HVAC system is going to be under a lot of pressure. And that also is an input to how you perform your tests. If you have a new facility and you've just turned it on and let it run for a day, that might not give you the full picture of how that's running during a summer where it needs to run 24/7, 365 days a year. So there are some considerations in as to how much your HVAC system is operating and how much ice can build up, and you get the full picture of this during just a single day. You might have to do several days. But moving on, the 5 components of a summer mapping. As I said before, when is summer? We're going to touch base on that, and I can't get.
Oh,
Yes,
you got it all.
thank you. Yeah, sun and radiation. It's just a small recap of what we're going to go through, and I think I'm going to use your keyboard here.
That's fine.
So first of all, when is summer? That's a question we get so often, and it's an impossible question to answer. The key thing to keep in mind here is, what is it we're trying to achieve? We're trying to achieve the highest external influence in the most extreme cases we have. So there's really not much more to do than taking a look at what are the mean outside temperatures. This is in Copenhagen, Denmark, and as you probably can see, Denmark is not a very hot country. And we're already complaining now here that it's 20 degrees outside. But that's really the only thing you can go for when trying to decide when it's summer. And the only real thing one can do about it is to have sort of a range of outside air temperatures that you would accept as summer. That would normally be something like the most extreme temperature plus minus 5 degrees. That would normally be accepted as sort of, this is the extreme temperatures. And the indications are basically that you would normally see that you need longer mapping periods. I mean, the test would run for longer. So where you maybe during winter could be sort of certain that it's cold, you would have it run for a week. The summer mapping might run for 2 or 3 weeks in order to ensure that you got a hot or at least a couple of hot days in your study as well. Of course, that might mean that you have a timeline that's shifting, but it's something to plan for at least. And the other thing is you have the risk of running out of summer. We're getting a lot of frantic customers at the end of the summer, which are just trying to catch summer, so to say, in order not to wait until the next summer arrives. So that's basically some of the dangers related to this. Again, it's just a part of monitoring the outside air temperatures, maybe from a standard meteorological institute or something that can give you an indication of when is summer. And the same goes for winter, by the way. The next topic again is about the sun and radiation heating. So I've just included the small graphic, which I think is very nice, and which basically explains the 3 different ways that heat and energy can be transferred. You can have convection, which is where the temperatures on the energy is being transferred by hot air that's flowing by or might be flowing by. So you'd often have this if you have a sun-facing side, or you see a candlelight, you can see the air or the smoke going up. That's basically due to convection. The air gets heated, gets lighter than the surrounding air, and it heats up. The other part is conduction. So that's where you have a close physical contact where the energy will travel across. That's basically something we see in insulation, right? Where we try to get it to be convection because that's less effective in air, as an example, to have still standing air. And then you have radiation heating, which is basically what the sun does. It radiates the heat on. And why does this matter? Well, this is an image of a warehouse, and I think you could all kind of see which side would we expect to be hotter than the other in this image, right? Keeping in mind which direction the sun will be on a summer mapping is really, really key to identifying the risks that are important in a summer mapping, right? So in this example, for example, there's a truck entrances both up and down here, and there will most likely be a much hotter side of this building than the other, because one is shaded and one is in sun. And that's basically because we have radiation coming in and heating the surfaces, heating the trucks that are delivering, heating the gates and everything. And one of the things, as I mentioned earlier, as an example, we see sometimes is that a gate that might be well insulated and doesn't cause any sort of serious trouble during winter mappings will actually heat up during the duration of a day. And because it's such a large chunk of metal and materials, it will actually radiate heat actually quite far out, that it's measurable at least until products really close by. So something that's not an issue during the winter mappings might be during summer mappings, because you have structures that are heating up and simply can't be cooled down efficiently with the HVAC system, which is often tuned in to get the entire facility, the entire warehouse to be within acceptable ranges. It will simply be a hot surface. Sometimes you can even feel it, both the radiation and also the conduction when touching those sites. Another part of this is, of course, also windows. We see a lot of windows that are being tinted, either tinted or simply painted over, trying to block out. And one of the things to keep in mind is that a lot of the radiation from the sun is not in the visible spectrum. So we've seen some tints that are optimized for human eyes, meaning that we're not blinded by them, but the sun rays still go through and heats up products. Not so much in newer buildings, but it's something to be cautious about, that the tinting or painting over windows is not just something you do. It actually needs a certain type of tint material in order to actually disallow the sun's radiation to pass through the windows. So those are risks that one needs to identify and measure for. Do we have areas that are being hit by the sun? I should mention that most facilities would not allow for windows to even exist in a temperature controlled warehouse. But we see when having older buildings that are being refurbished into warehouses, temperature controlled warehouses, that they'll have windows. And that's really something to be cautious about, because it can have a huge impact placing a pallet with product on the floor and the sun hitting it. It's a really large part of it. Parts of the risk we see associated with summer mappings. So moving on. So outside air temperatures, there's not only downsides to summer mappings. I think we discussed this earlier, right? That we see sometimes that by taking a risk-based approach, that there are studies which do not really make sense. One of I think the more funny ones is if you have, let's say, a 15 to 25 degree storage area, ambient storage, and the outside temperatures are somewhere in that range, let's say 20 degrees, as it is today, you're not going to see anything, because it might just aligns with the outside air temperature, and that's within acceptable ranges. We haven't seen, though, that companies have avoided doing power failure studies or door opening studies just because the outside temperatures were the same, because there is still a potential risk that you have equipment heating up above outside air temperature. But it's just something to be cautious about if you're doing a power failure study or door opening study, and it's not really possible to see any changes that might be because the outside air temperatures are just happen to be within the acceptable ranges. So that's one of the smaller, I think, more funny things to look at is well, there are actually tests that really end up not showing us anything, which is a good idea. Another part of this, when you have as well the temperature outside increasing, is actually that we see as an operational risk that equalizing product temperatures or package or whatever is being stored, temperatures can actually have a large impact on the HVAC system. So even like 5 degrees difference in the products that are coming, if they're in large quantity, can actually have quite a lot of impact. And not only do we need to monitor for this by loggers, but it's also a risk to the process itself. So do you receive goods directly from trucks and put them directly on pallet shelves? Well, you might affect temperatures for the products being stored for long term, where in some cases we've seen companies having to do an intermediate equalizing storage area. So you'll receive the products, wait for them to equalize to the surrounding air temperature before putting them on long-term storage.
Do you have a special test for that? Because that's not a
That's a really good question, because we would normally advise that temporary storage areas are also part of the mapping exercise. And we normally like to keep the tests where you'd run the facility whilst monitoring as a PQ, a performance qualification. So we often advise, this gives absolutely the best image of how well your products are being stored, is that you install loggers as per your protocol, and then you start using the facility, or at least simulate it. Because this is something that's very hard to detect if you don't have actual operations going on. It's a really good question. Of course, during a mapping, we'd normally measure air temperatures. So we don't normally measure the product temperatures. I think as part of acceptance controls, where you accept and measure product temperatures, you would find out that temperatures are being elevated. But it's not always that we're seeing product temperatures being elevated above acceptable ranges. It's just that it does have an impact on your cooling needs, as an example, when products are really coming from all these different sources, as we have here.
Maybe we could just make a question out there. Do you use MKT?
Yeah, it's a hot topic.
Again.
Yeah.
There you go. Okay, new poll. I'm just gonna see how can I get this up. There you go. Start poll now.
So MKT, mean kinetic temperature, is actually is something that we're seeing at the moment that is being used more and more. And for those who don't know, it's basically an advanced form of an average, one might say, with the activation energy for different types of products. So it requires you to have the activation energy for the specific product that you're storing, and it will actually give an indication as to whether that product has been influenced by any temperatures outside the acceptable ranges. So we're actually quite interested in seeing whether people use it, because we don't use it a lot with our customers, but we're seeing it being requested more and more.
Yeah, so it's kind of like a trend, you might say, and it connects to this particular case that you mentioned just before, I assume.
Right? Yeah, absolutely.
All right, but let's just give it a couple of minutes, and we can come back to it in the Q&A.
Absolutely.
Okay.
So again, equalizing product temperatures. Remember that for products to cool down, you'd need the HVAC system to perform at an increased rate. And that can have an influence also in other areas of your warehouse. We sometimes see this where they'll start using and they'll get in hot products, one might say, being stored, and it's other areas of the facility that then are becoming much cooler. And that's basically because some systems can't really recognize where the increase in heat is, and they will compensate in other areas of the facility. So it's really something to be wary about. So there's a question here from Vipul. No power failure / doubling test recommended when external temperatures between 15 and 25. What about 30 and 35? So that's a really good question, actually. All standards and guidelines dictate the use of seasonal mappings. So it is a risk to run in terms of the auditor not to do the opening test and power failure tests, even when the outside air temperatures are within limits. So the question might be, how much of risk are you willing to take? I would definitely run a power failure and a door opening tests if you have temperatures between 30 and 35 degrees. Absolutely. Because there might also be other heat producing equipment inside the warehouse that you might not know the effect of during a power failure test. And also people asks, is it compulsory to perform power failure and open door test when products are in place? That's another really good question. It's compulsory to, or at least mandated by the standards and guidelines, to perform power failure tests and open door tests. It does not necessarily have to be with real products. because that could potentially ruin quite a lot of products. What we often see is when we do our temperature mappings is that use dummy products. So you'll use something roughly the same size and maybe thermal mass if you're capable of that on the shelves, and then you'll perform your studies on that. Because it's a high risk to the product. It could be a very expensive mapping, absolutely. But great question. So the use in general, the use of dummy products is a really good idea because it gives you the same data on whether the homogeneity and stability of temperatures is within the acceptable ranges, but without risking actual product.
How do you do that in like, I don't know, a 10,000 square meter warehouse?
It's a really good idea. So the ISPE guideline basically gives the recipe for that. They're saying, first of all, if your facility is symmetrical, so let's assume a square as an example, and you could divide that into 4 similar alike looking squares, you can basically take some of your testing and perform it on that square alone when you have these high demand tasks such as filling in dummy loads. It's much down to the different requirements. But now we're talking GxP, so there's a large range to it. We're seeing our customers filling up pallets with cardboard boxes on there. But as you mentioned, if you have 10,000 square meters, it's a lot of cardboard boxes. We're also seeing the use of tarps. So basically having down these large tarps to limit the airflow, and that simulates goods as well. There's a lot of
right. So you would hack your way around it and try to really emulate a placement filled out up with goods.
Absolutely, yeah.
All right. Okay. Good. Should we just move on to the last slide?
So the last here is basically whether there are any questions, and we'll try to give some answers along the way.
And I've been dying to ask a question also, or maybe like 10. But and I will look through the chat in just a moment, but I have one question here. And that is, often we talk about the risk-based approach and the ability to let's say find out that there are certain areas within a storing facility or a unit unit that you can't use because it's not following the standards that we've set up. But what about summer and winter mapping in this, like the summer mapping? Because you have this gate that you just know heats up, and you have this area that you just know. You have this because the airflow is just bad in here, and you just have this zone which is colder during the summer than it's supposed to be in order for it to cool down the entire facility. How do you come about that from a like summer winter mapping perspective? Can you isolate an area just during summer?
That's actually a really good question, and it's actually we've seen that happening where a customer knows, because we did the study, that certain areas are really not within acceptable ranges during summer. I'm quite certain it was summer. It doesn't matter, winter or summer, where they would actually exclude the use of certain areas during summer. So that is a possibility. I would say often tuning of the HVAC system can resolve it. But yeah, you might end up in situations where there are certain areas that can really not be used. And the constant monitoring one should have should alert you when certain areas are not really fit for use anymore. It's rare, but it does happen that certain areas are not, especially when we're seeing refurbished warehouses that have not been used for controlled temperature storage are being then reused for that purpose without actually that being the purpose when the building was built. Absolutely.
All right, then let's show the result of the. Can you see the poll up there? Yeah, you can. Perfect. So it seems like there are a trend here with MKT, right? 29% actually using it.
It is a useful tool using mean kinetic temperature for estimating. I wouldn't say outliers, but sort of deviations in temperature in terms of the acceptable ranges. I would advise though that one reads thoroughly on the topic, because MKT can be heavily influenced by how much data you use for the calculation, what your activation energy is,
Yeah, isn't it kind of acting as a strange buffer between the air temperature and then the actual
Yeah,
energy
yeah,
in it?
yeah. One could say that, but as is with average temperatures, I mean, if you
Oh yeah.
have a temperature spike
Mm-hmm.
at some point due to a door opening test or a door opening or whatever it might be, that average temperature, if you just take 5 days after that with good temperature data and you average it out, it doesn't have an influence. So MKT really needs to be used with caution in order to give actual results. So there's a question here. Do you suggest is there a requirement for 1, 2, or 3 point calibration of your testing devices before performing your mappings exercise? I can't actually remember whether it's requirement, but metrologically, it only makes sense. Yes, okay, now I remember the WHO guidelines do require a 3 point calibration, and that is due to the metrological reasons or the metrological calibration of the devices. The error of the measurement error of any temperature device will almost always be a second degree polynomial. So it'll be a curve like this. And the only way to define that curve is with 3 points. So there is a technical reason behind why one would need a 3 point calibration, and it only does make sense. And most of the standards and guidelines mention this as you need a calibration. If you have, let's say, an ambient storage, 15 to 25 degrees, you would need a point in the middle, let's say at 20 degrees, and then points at the lower and upper end. What we normally would advise for is basically don't take 15 and 25, do like 10 and then 30. Because if you have outliers, let's say during a door opening test, you want to be able to trust that data as well. And you theoretically can't do that if you haven't calibrated that range.
Yeah, is it again like coming back to calibration? Is like you never really go wrong in the park if you choose an accredited calibration laboratory because it's really rare that we see companies asking for.
We see close to none that do not require a accredited calibration. Otherwise, you would need to be in very tight control of your calibration supplier. You could do the evaluation yourself, turn up for an audit, but it's a lot of auditing for calibration. But yeah, in most cases, for most GxP rated stuff, especially when you're approaching GMP and GDP, will have requirements for accredited calibrations. Absolutely.
Yeah, so it de-risk a lot. And
Yeah,
yeah,
absolutely. Yeah.
okay, cool. Jakob.
Yeah. Sorry, there's a really good question here from Mohammed. Based on what the cold spots and hot spots are defined, based on max min temp or relative humidity, even if the mix MQX detected readings was 1 or 2 times over studies, or based on the highest number of min max occurrences density, or mean temperature mappings plus standard deviation, or max mean MKT. It's a really good question, actually. It's a lot of information. If I'm getting your questions correctly, is basically what should we define as our hotspots and cold spots? This is one of my favorite questions. I'll keep myself short here. So, what we normally advise for is saying, well, the max mean temperatures do not in themselves say anything about where there's hotspots and cold spots, because a single erroneous temperature, a single point of temperature, does not give any indications on what the hotspots and cold spots are. So normally I would say start off with the mean temperatures, because those give the general tendencies as to where the hot and cold spots are. And then on top of that, we would always look at a distribution chart. So we have these whiskers where we can say where is the mean, where is 50% of our measurements, and where are 95% of our measurements. And I'll try to see if I can get a link for something that can show that over time. That normally gives a much better idea of where the hotspots and cold spots are. The other part of the question is basically, do you take into account the MPE? I hope that was the question at least. So basically, the maximum permissible error. So to which degree did we calibrate our sensors to? And yes, I would introduce that as well. So for example, with the averages, I would say the averages plus minus the MPE, all that fall within that would be our hotspots and cold spot candidates. I hope that answered your question, Mohammed. I could talk for an hour on this topic. So,
Jakob, I just put on another slide because it was a bit boring just to look at the QA, so you can look at the benefits of using digital tools also.
There's another great question here from Ronald. Is an outlier excursion temperature results purely based on the temperature or on the combination of temperature and time? These are great questions, actually. Yeah, again, that's why, as well as to Mohammed's question, I would normally look at either averages, because those take into account the time, but also the distribution chart. So you normally would see temperatures sort of distributing them as normal distribution, sort of, and then looking at the 95% percentile or the 90% percentile and see where is it reasonable to think that that position could have temperatures in that range. So that's a really good indicator. It does not work for door opening studies. That's really important to remember, because then we have spikes of temperature, and then you can just then it's really dependent on how much time after that you take the temperatures. But for door opening studies specifically, what we normally do with each of our customers, defined what is an acceptable return rate or return time. So yes, you will get an outlier if you open the door, but for how long can we accept this? And normally in a warehouse, we would say something like 30, 45 minutes, maybe 60 minutes before the temperature needs to go back in range. The other part of door opening tests that are important to note is that it also depends on how often do you do this a day. It's not very efficient if it takes half an hour for the air temperature to stabilize. If you open it every half an hour, then it will just constantly be out of spec. That's not really. So
we're back to the operational risk, right?
Exactly. Yes, exactly. And that's why it's so important to get all parts. It's also one of the topics we touched base on in our former webinars. So important to get everyone involved.
Now, how do you do that? When you come in as an external consultant and you have a company, and you get hired by the quality team, and then you obviously also have the facility team there doing their work.
I would say some of the places where we can add the most value, I would put it this way, is where we are allowed access to both the QA unit and where they've put together a team of QA unit, operational team, and management as well, and the facility team, if those are different teams. Because not only today, it's one of the key elements, it's not only today we want assurance compliance. What happens if in 2 years you'll get more customers? Well, then you have an increased usage of the facility. And that's just so important.
We have another question from Jonathan.
Yeah.
So if a mapping is done and there's a finding, once corrected, such as putting a plastic curtain on the door, is another mapping exercise expected?
Also really good question. I would say it's a hard question in the sense that we've seen it both work and not work with auditors, I should conclude, both auditors and customers. So in my view, if you can isolate an issue to or any deviation in temperature readings to a very specific issue, and you have enough data to rationalize that this originated from this specific issue, yes, then we've seen cases where it can actually satisfy both auditors and customers, and of course the quality units themselves, to mitigate whatever issue there was and then do another readings. Normally would say yes, for example, with a door that needs to be further insulated or another air curtain or a plastic curtain on, if you place the same data loggers as did readings outside and then just do another layer behind it, and you can show that has eliminated the issue, yes, normally we would have, normally it satisfies regulatory requirements, absolutely. But it's not a topic that's really discussed in any of the specific mapping guidelines and standards. It's a really tough one now.
Because that's almost, as I understand what Vipul is asking.
Yeah.
Like, is there any guidelines for such, I don't know, timelines or anything?
Yeah, it's a great question, Vipul. There is really not. And it really has to do with the fact that products have massively different thermal masses. So you could imagine if I take one ice cube out of the freezer, it's going to thaw quite quickly. But if I take a whole liter of water in the freezer and take it out, it's going to take more time to thaw. So based on the size of your products and the thermal masses, you need to define whether how much time that is. Normally, if I am to give something, I said I didn't want to give something like 30 to 60 minutes is normally within that range. Yeah.
Right. Okay. Jakob, we are at 1 hour now, 20
Yeah.
seconds ago, and I see people thanking, and thank you all, Jonathan, David, Ronald, and Abdia, for being here, and the rest of you also. It's been really interesting, and I would love to just come about more time, but it seems like you also have a job to attend to. So thank you very
Thank you
much
so much
for
for attending, and
today.
thank you for all the great questions, or really good
Yeah,
questions,
mega good.
actually.
And maybe like keep the questions coming. You're free to reach out for us. We'll happily help with trying to geek out in this topic also. And we can talk, as you can see, for hours and hours about even something as particular as a summer mapping,
Yeah.
because there is a lot more to talk about. But until then, we'll catch us online on LinkedIn, like via email. Reach out if you have any requests. We're very happy to help you out. And until then, have a lovely day.
Yeah.
Thank you very
Absolutely.
much for attending. Bye bye, all.
Bye.